Yeah.
So, hello everyone. It says I have the notification you are live. It looks good. Let me put our guests here on the main screen and
Hello.
allow me to say hello and very good morning um, to Gary and Johan from DURAG and AP2E, our dear guests for today's Meet the Expert webinar. And I'm very happy and excited to have you on board and
Thank you.
this webinar.
Thank you. And good morning from our side to you as well.
Yeah, thank you very much. Jemson, we should not forget about you. I think we don't. As we were kidding, it's time for a drink. I mean, you can make it. It's perfect sundowner timing now in Singapore, and yeah, I'm very happy. It's only 2 days ago since I could visit you and I could visit the region. So very nice, and yeah, as I said, I'm quite happy. Everything okay, Jemson?
Yeah, I was just wondering, have you overcome your jet lag now?
Yeah, sure. No, that's okay. It's fine. It's fine. Yeah, obviously the webinar is not about us. It's also about all of the people out there attending. And we have a message here from Mr. Mena. Good morning from Brazil. We have a message from Nigeria. Is also Mr. Sani attending, which is super nice. Indonesia is there. So yeah, it's slowly popping in all over the world. And I think it's just great to see that everyone's here. Okay, so guys, before we get started actually into, I would say, one of the region, which is maybe one of the most famous region for vacation, or one of the favorite region for vacation, to Marseille in France, and to our colleagues, allow us very shortly to give an introduction into this webinar here today. So as I said, we are very happy to have the colleagues from DURAG and from AP2E here on board, and very excited because this is something we can say it's a special sampling technology. And this, in the preparation to this meeting, was also something which caught our attention. We were saying, okay, let's see some new, some innovative concepts for the sample handling. And therefore I'm very happy to have you on board. Jose is also there from the Middle East. Good morning, Jose, or he's in the noontime, I think, so he has to wait for his sundowner a little longer, but I think it's great. Okay, Jemson, maybe you can shortly move to the next slide. We decided to make this very short because we wanted to give, we saw the great preparation work our guests have done today, and that's the reason why we did not want to occupy too much of the time with some internal kind of things. But allow me to use this opportunity to invite all of you to AGEMA, 22nd to 26th of August here in Frankfurt. And we are very much into the preparation work, and we are also looking forward to see and to meet you there. We also offer free tickets. I think, Tobias, if you could be so kind somewhere in the background and post the ticket link also to the in the show notes, so to say, then this would just be nice, so that we have all of the informations here and that you can sign up for free. If you need any more support, I think that it's no problem. Just let us know, and we will help you with that. Okay, so Jemson, let me see. I think, introduction into the enhanced gas monitoring as a result of low pressure sampling. So that's what I said. something new, something innovative, and something we are very happy to know more about. So, Jemsen, what is your expectation for today?
Well, I think we're gaining a lot of attention, especially in Southeast Asia, the territory that I'm occupying. Yeah, AP2E becoming, especially in the process industries, very getting a lot of curiosity.
Okay, yeah, I think that's good to hear. So then, Gary and Johan, the mic is yours, so to say. We are very happy to hear your introduction and your presentation.
Thank you for the good introduction. Hello, everybody. Thank you for joining us. As Jörg already mentioned, wow, what an audience we have already from across the world. So thank you for taking the time to join us here today. I'm Johan Koop. I'm from DURAG Group, and I'll give you a bit of an introduction into our company, and we'll dive deeper bit by bit into the world of AP2E with Gary.
Super.
So if we're ready, I can proceed.
All right. That was my call. Yeah. Okay. So presentation is there. Everything seems to work.
Let's give it a go. So the first thing I want to put up on the screen is what we stand for, and it's technology for a clean and safe environment. It is a really powerful principle within DURAG Group, and all the employees are united under that principle worldwide. And you'll see a little bit today of how our products fit with that principle. The first thing I would like to do is click to the next slide, which shows a video. It's a quick video, but hang on in there, because in a very short time, you get a little flavor for what we do and who we are. So,
okay, did you click? Yeah, okay, great. Super. Now it's working.
So, if we're ready, hold on, let's hope it works. Here we go.
Do you have any doubts it's not working?
Never, of course not.
Wow, I think the numbers, Jemsen, I shortly saw the video before, is quite impressive, huh?
Yeah, and you should see there, yes, Singapore is highlighted.
I think it's a German center, right? Is it where the location is?
Yeah, there it is. That is our headquarters, and the fastest tour you ever had through the factory.
Okay.
It's nice. Of course, we are not there in Hamburg, but it's nice to get a small a feel for it, a small vision of it.
Yeah, absolutely. So the let's say the SEMS and the emission monitoring is something you put at the first priority, or which is in the video in the first place.
Yeah, I mean, look, the portfolio is ever growing, and I'll show a slide after this, which just gives a few of our brand names. But I mean, as we ebb and flow through the years and looking at different industries, everything is important, and more there are new and more interesting industries popping up all over the place. And it's with companies like AP2E and technologies like theirs that we can really get stuck into those industries, learn more, and develop further. And you see on this screen here, I know we had some numbers, but a little recap there. Actually, next year we're 75, so it's a big year for us next year.
Wow.
There'll be a lot of parties, so keep an eye on LinkedIn for that, and we'll be doing events around the calendar. And the group, roughly 580 employees across 7 brands. AP2E is one of those. Our production facilities are all in Europe. Again, here in the south of France, we are sitting in one of them. And what you saw with the video, you saw the globe. We have 15 offices, but where we don't have an office, we have a partner network that supports us across the globe. If I jump into the next screen, I start to explain a little bit more about the brands and the products. So again, what we're about is technology for a clean and safe environment. And how we do that is we supply products and services that make an important contribution to a sustainable, low emission and environmentally friendly world. It's changing now more than ever. As we've all seen, there is increased attention and focus on reducing emissions, becoming more environmentally friendly. And even with our combustion portfolio, we're contributing to that. So how do we look at our business? How can I explain the group side of DURAG? I think this will help. We have a combustion and safety business unit, which is doing ignition systems and burners, video cameras, flame monitors, and flame analysis. So it's all about the combustion side. Then we have an emission and process side. So it's looking at the aftermath of either a chemical reaction or a combustion process, or even ambient air itself. And finally, a new and growing important sector of our business is the tunnel and traffic monitoring business.
Okay.
What I want to do is put the brands there so you can see. So maybe you don't know DURAG Group, maybe you don't know AP2E, but you might know one of these. And together with the DURAG Group family, and somehow or some way, we aim to have a solution to support different plants, different projects, different industries in achieving higher standards of monitoring and, again, contributing to that environmentally friendly world.
Okay, super. I think that's impressive to see.
There's a lot of products, a lot of brands, and a huge amount of industries. And I put this slide here because maybe you're thinking, oh, you know, I'm a power station. Is there something for me? I'm in a university. Is there something for me? And you can see here, really, the possibilities are almost endless. If there's something there and it's measuring gas or it's measuring or to do with combustion, then we're usually involved in that. Of course, today we focus on the environmental side, so I stick with this from now on and I begin to taper down to AP2E. And here you just see a small sample of what it is we do in emission or raw gas applications. And what we've got on the screen, starting at the top left, unfortunately I don't have a laser. So you have the rack mount analyzer on the top left, dust analyzers to their right, flow analyzers in the top right corner of your screen. And then on the bottom, we have AP2E sampling, we have a mercury analyzer, and importantly as well is the data system, which is taking the information from all of these products and doing something useful with it, reporting it.
So, Johan, from my understanding, there is some, I would say, extractive solution, typical or classical extractive solutions, and also some inside measurements, or
exactly, in situ. For us, for gas monitoring or sampling, so mercury or AP2E, we're using extractive, but for our dust and flow, it's predominantly an in situ measurement. And again, just to add something to that, how does it fit on a plant? What does it look like? Maybe this slide quickly shows you, where is DURAG sitting with me? Where can it work? And this is a SEMS application or a raw gas application. There's a lot of data, but it's just a quick view of exactly what you described, Jörg. Is it on the stack? Is it in situ? Or is it extractive? Maybe it will work here. Maybe you can see that. Down here is where we're funneling to today. It's our extractive gas analysis. This is where we're talking in more detail shortly.
And Johan, maybe sorry if I this question. I think it's just interesting. Do you see that? I mean, having a portfolio like this, is the dust monitoring always some of the first things which are implemented? I mean, you gave a worldwide overview. Is this always which is there, let's say, at the very beginning of emission monitoring, or what's your experience on this?
I mean, for us as DURAG Group, dust monitoring is where we come from. It's our foundation. So when I told you we are 75 next year, some of the earliest products were in dust monitoring. And because of that, because of our because we're well known for the dust monitoring, the flow monitoring, sure, for DURAG Group, it can be dust monitoring that begins a project. Yeah, it depends really. But since AP2E joined the family, I guess it's changed quite a bit, because there's plenty of applications where there is no dust monitoring at all, but there is gas analysis.
Okay. No, I got it. It's just my feeling, and I just wanted to know. I think I also asked this several other people before, because I always think, the dust is something you can see. Where and when I remember places, I don't know, like India or Jensen, also in your region, somewhere you travel and you see a lot of really pollution. I mean, pollution from what you can see is always pretty much tied with dust, right? Because you can see it, what comes out of the combustion process. So I was just wondering.
You're right. Of course, if you can see it, maybe it attracts the most attention, and it's the first thing that's targeted. Sure. So the dust and the moisture can create a big cloud, but also it could be the smell.
Sure.
And here, where you say, "Oh, maybe we need to monitor that too."
I mean, the dangerous thing is in the gas, is invisible. It's nothing you can. But I just found this very interesting, because this is also something.
It's a good point. And maybe the next screen kind of contributes to that, because you see that AP2E isn't just on a stack. It's not just monitoring process. It's also ambient, the air we breathe. And you talk about, well, I have a stack. It's quite dirty. There's a big cloud. Here we have the products of some of the products of our group for monitoring the quality of indoor air, ambient air, or for research purposes. And that is particles, fine particles, and also gases. And a few examples there, like formaldehyde or H2S, smelly gases. So again, it's these products that help not only a government to monitor or an authority to monitor, but it helps the company, it helps the industry to understand more about what's going through their process. Knowing that can help them to be more efficient, maybe even save money, and improve the conditions for the people around the site.
Yeah, I think that's always nice to show that this is maybe the two main showcases we have, right? The one side is really the emission monitoring, sometimes tough in terms of price requirements, because in many countries, I would say, every or most of the operators, they would just choose whatever is sufficient, but not more. And I think sometimes when you do the process analytics and process optimization, that's, I would say, is pretty much what you are talking about, Johan. You talk about business cases, right? So you need less ingredients, components, whatever, energy. If I see now, I mean, I think in Europe we are all in the same situation, that we have to rethink the gas resources, and so process plant optimization in terms of energy and components will always be there and will be a very big topic, right?
I think it's a growing topic. You're right. We look at alternative fuels. Some of those are related to political situations. Some of that's related to the growing interest in CO2 emissions. but we also have power stations, for example, where the load is fluctuating greatly, where we try to only supply what is needed in a production facility. The facility may be producing food or power, and here you need products that can accurately measure and monitor and report for process reasons, and of course for environmental reasons. And of course they have to perform. They have to come on when they need to come on. They have to give the measurement with a high degree of accuracy. And this is absolutely our focus. Absolutely.
Okay. Yeah, great. So I think we have to keep the time.
We keep moving. We keep moving. One final slide from my part, because I showed a stack. I just want to show a slide with a plant. Again, it could be any plant. You might be making food products or pharmaceutical. This is typical waste incinerator or grate-fired application. What I want to say, everywhere you see a plus, it's a application for us. And that is the red ones are combustion, the green ones are emission or ambient air.
Okay. Now I think it's very clear what you said at the beginning. You said the left part. Okay. Now it's very clear. Okay.
Exactly. Yeah. You can see where all of the brands suddenly arrive as a solution. Yeah. So that was a very quick and deep dive into DURAG very fast. What we want to do, of course, is focus on AP2E, which is why we're here today. And for that,
and I think we can give a short impression. Gary, it would be super nice if you can walk us through this video a little bit.
That's starting with a quick presentation of AP2E, focusing on our production facility. So as Johan explained very well, we are part of DURAG groups, and we are provider of new solution for gas analysis in particular, with a very innovative way of answering the needs.
That's it. And this is, we could of course run through the factory, but it's not always so easy. There's a lot of sensitive projects, so we use this video to try and take you as a tour through the facility themselves. It's a bit more efficient, I think, for us, right?
It's a good introduction to AP2E.
So that shows your R&D facilities, and this is a production itself now.
Now you're watching the production itself.
Okay.
You can see wall-mounted analyzer as the one we have behind us.
Okay.
And that's
it. Earlier on, you saw the optical mirrors being aligned. There's lots of different processes.
That's the technical part, more deep into optical cavities.
So this is mirrors, right?
Exactly. Mirrors and lasers, tuning before production.
Okay, and this is the qualification at the end, the calibration of the.
That is here you can see the same emission probe, and now we're switching to the metrology part. Of course, I don't know if the video is.
I think it
still.
No, I just stopped it.
Okay.
I wanted to.
You will see just after that the metrology part. Which is the heart of our company, and the know-how of AP2E.
There you go.
Great. Thank you so much for this. For this
we
video.
wanted to give a flavor, right? We didn't want to just be here and not show it. So at least now you can see the different stages, the different processes, and even some of the sensitive work that they're doing there underneath us right now.
Okay. Thank you for sharing this.
So I think we can jump back to the slides.
Okay, sure. So there we are.
And
You have to double click.
Yeah.
And again.
And again.
Yeah.
And so now we can focus a little more in one of the many projects of DURAG Group. And us at AP2E, so we are based in France, south of France. And we have a lot of partners, thanks also to our colleagues all over the world. And as you have seen through that great videos, we are now about 65, and we are completely technology oriented, with more than half of us engineers or PhDs, and focused on improving continuously the techniques and in an innovative ways. So we have some experience, not as much as the 75 years of DURAG, but still we have now more than 1,000 analyzers worldwide, measuring plenty different gases, and as Johan explained, the applications are completely various. We can offer solutions in process, but the same way in emissions or in ambient air. And
we like it.
So Gary, if I may ask, when was AP2E founded?
When it was founded in 2006, I think.
Like a startup. I mean, not startup in terms of experience, but compared to the age of other companies.
It has been founded by three guys who were already very experienced with a huge background in gas analysis.
Super.
And
okay.
They worked in partnership with a French university at that time, and still we are working with them currently in order to develop this unique solution, which is composed, of course, of the low pressure sampling, but also working with the OFCIAS technology, which is the optical part. And they are really working together inside our analyzer to provide this kind of solution.
Super.
So now we are growing really fast, and I think we joined DURAG Group in 2018, something like that. And
2018.
Now we're working
Super.
together.
Okay, interesting. Yeah.
So let's
get to it.
Yeah, let's get to it. Let's dig a little more in the techniques and focus on what we are here for, the low pressure sampling. So this is our way to sample or in any kind of application, whether it is, as you can see on the right, the emission probe. So for all kind of emission application, whether it is waste incineration, large combustion, or any other, even in production plants, we have solutions. And on the left, you can see a zoom on I would say the key part of low pressure sampling, which is the sonic nozzle, and maybe you can see it as Johan.
You can see a real deal.
Yeah, look, let me put you guys in a little bit bigger screen. Hold on. Yeah, that was the right one. So Gary, the probe we saw, the extractive probe, is that coming with a heated? Is this a heated tube in the probe, or is this just a standard tube?
No, it's not mandatory. We will go into that, that point just later on. But it's mainly composed of sonic nozzle, filters, and then it starting right at the sampling point. By the way, as Johan is showing you. This is the sampling probe, and
Sample in here.
yeah, the probe, and this is one of our solutions. So this is an ATEX version for process monitoring or emission monitoring, actually.
So this
So,
is
yeah,
our
all
line for illustration purposes.
Yeah.
But actually, could this line really work on an application?
Yeah, clearly it's
So it could,
as you see it here, we can make
Okay.
it work, and use it.
so it
as
could
it
be
is.
that I have an application here, I have my analyzer mounted, and
Yeah.
it really can be.
Yeah, and actually, we are currently monitoring in the room right now.
Okay.
So
course.
we will see that just after some slides with another analyzer. So maybe, Jörg, we can go back to the slides.
Yeah, no problem. Here we go.
Here we are, and so as we explained, I think now it's completely clear. We have an extractive solution, so we start with here, for example, it's a continuous emission monitoring. So we start with a sampling box directly on the stack, and then we draw a line, heated or not, up to the analyzer. And this time you can see, as we have seen the wall-mounted version, we can also have a cabinet version like this one, with at the end and here at the bottom of the drawing, the pumping system, which is the second key of the low pressure sampling. We have the sonic nozzle and the pumping system, and without one of these, we won't be able to have the low pressure sampling.
And this is probably something a lot of people recognize when they think about gas analysis, right?
Yeah, I think it's very familiar to
So
a lot
it's
of
good
people.
to see, because this may be a bit different.
Yeah.
This may be a bit different. Let's see where it goes.
Yeah.
So if we dig a little more in that schematic, you just see we have still the process, and inside the sampling box, or directly in Johan's hands, you have the sonic nozzle.
Maybe now's a point where we could show what is a sonic nozzle, because this is our sampling point here. This is point B.
Yeah.
What's part of this?
Yeah,
What's
inside?
in the middle?
Yeah.
So do you have an example of it?
Yeah. For example, I have one here.
That's
in
a
my
sonic nozzle.
So
Okay.
maybe you won't be able to see anything.
Yeah.
It's very, very small. What is a
very
sonic
small,
nozzle?
yeah.
Actually, it's a small tube with a very thin orifice on it. This one, for example, is 200 microns. So it's very, very thin.
So it's the sample gas is coming, and it's the only way. Only way through.
Yeah, only way through, and this is how it allows us to reduce the pressure after that piece.
Okay, so that means in the sample tube, still until the point where you have this nozzle, you would have a higher flow, so to say, or
theoretically in this first section.
Yeah.
Or this first section, we have a filter here or something.
Yeah, that's it.
So it's really this, however long the first section is, sure.
Okay.
After the nozzle, which in this instance, I will show you just side by side. You have the nozzle. Is here.
Okay. Wow.
After this, this is your gateway. Afterwards, low pressure. If I'm right, Gary.
Exactly, you understood completely. And so it started right at the sampling point. Yeah, directly in point B in the slides.
Yeah. So what is the let's go ahead. I think it's very interesting to understand.
So same thing we have as this one. We have a sampling line, and this is our cavity inside the analyzer, the heart of the analyzer, the measuring cell, and then the gas is sucked by a vacuum pump at the end, or it can be integrated into our wall-mounted, or it can be on the side, on the bottom of a cabinet.
Maybe, I mean, I'm just thinking, is it good to show it? Is now a...
Yeah,
The
I
right
think
hand?
it.
Yeah,
Yeah,
maybe it could
I
be.
think
yeah.
Could be.
think it would be. Mhm.
Yeah. Could you switch to my camera, yeah?
Sure.
Yeah.
Oh, now
Lovely.
we have so many screens here. I just have to.
So now you can see it. So this is we wanted to share a real application, a real analyzer monitoring in live the ambient air in the room. So you see it here, and if I move, I will try to move slowly. Here is another version, the rack mount version.
A more classical version, maybe.
Yeah,
People are used to a 19-inch rack mount analyzer.
Yeah. So
Okay.
you have
Yeah.
same thing. You have here the sonic nozzle, the process probe.
So I'll take that. So this is taking the sample from wherever, ambient air, process, stack.
It goes
down the tube
inside the analyzer, and it's sucked by the pumping system here, which is also a patented part of our patented technology.
So this is the vacuum pump we see there.
Yes,
Gary.
exactly.
Yeah.
Yeah.
It's fair to say then, like you said earlier, that actually they're both significant parts of the measuring system. And both of these allow us to achieve low pressure sampling.
Yeah.
And I think that's important to note, that actually the pump is as important as the handling itself at the front end.
For each application, we are designing the size of the sampling, the sonic nozzle, and also designing the pumping system accordingly in order for them to work together and make an efficient sampling.
Okay, so Gary, for the understanding, the probe, the nozzle is connected to the analyzer or to the pump, and when is it connected to the analyzer? So what is the order?
It's connected before the analyzer. You can see. Well,
this is the. So I have the probe here, and the probe is coming through and into the analyzer.
All right. Okay.
The gas will follow through the measuring cell, and the pump is behind. It's sucking through.
Okay.
Yeah.
Okay.
Exactly.
But I mean, we could show it if you're ready.
Yeah. We can also show a bit more about it. So inside this box, you have some laser. So of course, we have to switch on the analyzer before, for safety reason.
We'll turn it off. Yeah.
for our own safety and to keep our eyesight. So
yeah,
please go ahead.
You shouldn't get cutted or anything hurt from the laser. I think.
Yeah.
Not live in a LinkedIn webinar.
Okay, thank you. And this is the second heart, I would say, of AP2E's technology. This is the optical block. So with the measuring cell, as you have seen in the slide just before, the laser and some optics on the bottom.
Yeah, maybe you can see if I just point. I won't touch, but here we have optical mirrors and reflectors. It's an incredibly high reflectivity that allows the product to have an incredibly high sensitivity or selectability.
Yeah, exactly.
But just to follow on, Jörg, now the shell's off. You see my finger?
Yeah.
Here's the gas coming in, down the stream, and into the cell. And then the measuring cell here is having, I mean, Gary, stop me if I'm going wild here, but of course, you have your laser in the cell, and then the gas will leave.
Yeah, from this side, but also from the other side.
And that is what this second one is, and it will leave because the pump is sucking the gas through the cell at a very low pressure.
Very interesting. Very interesting. Guys, may I ask one question? It looks relatively empty. There's a lot of space left. Is this?
Well, this version, this is an excellent question, because actually this version is a very basic one, and though you still have seen that we are able to measure 3 different gases with only one laser. In this application, but we can also add another cavity just on the side of the first one, with a different setup, and another motherboard, some electronics also, in order to increase the number of gases we can measure, and give a turnkey solution for example, for SAM application, when a lot of gases are needed to be
So so this is like the basic configuration, and then you can add, depending on the application, you would be flexible to add more benches to measure more gases.
Exactly, and more lasers too. Just on one cavity here, we can have one laser, as you see, but we can also put a second laser just after it, so we can have up to 4 lasers into one analyzer.
Wow, that's impressive.
Then it's quite busy in there.
Yeah. I can imagine.
All right.
Nice to see. Thank you for sharing. So I will remove this camera, and I will put you and the presentation on again, because I think from my side, Jensen, I don't know what you think, but I need a little recap. I would say. Actually, what I'm doing, Gary, maybe this is not a new exercise for you, but I'm trying to compare the traditional way of sampling with your way. So I think at point B, we would have like a traditional heated gas sampling probe, which is responsible to do the filtration, right, of any dust or any remaining parts which you don't want to have in your sample handling system. And typically C, the sampling line in our cases would be a heated sample line, which is heated above the acid dew point, because we are still hot at this point in a traditional system. And so I think it's just very interesting to see also the comparison. Jensen, maybe I can just shortly show the comparison. Let's say typical sample handling system, like I said, we would have the probe, we would have the heated sample lines, and then depending on the measurement or on the analyzer technology, we would either need to dry the gas, which means gas cooler, we cool to dry the gas, or we would have like a hot-wet system, FDIR measurement, for instance, which would also allow to have the hot-wet where there is no cooler than in this case needed. So it's just as I'm trying, I think
a good comparison.
The people are very familiar with this traditional way, and I think it's interesting to understand your way and the difference, and obviously also the advantages.
Absolutely.
And as you said, well, traditionally we need these 3 components, as you have shown us. Here with AP2E, we still need a heating line, for some application, but still sometimes it's not necessary. And as you explained very well, we have you can have cold and condition monitoring analysis, and you can have hot-wet monitoring directly with the raw gas, and that's where AP2E is positioned.
So if I may ask, Gary, because there's also one question, we will have the Q&A session at the end, but this is just a question which is also popping into my mind. So if we would have a lot of dust, because process measurement, I mean, we recently discussed when we have the SEMS, there's only a limited amount of dust left at the sampling point, but especially when we talk about process measurement, we might be in a very dusty part of the plant, right? So how do you do this in your sampling?
Yeah, that's a good question. Well, as you said, as I think any kind of extractive analytic system, we have some limits regarding the dust, but still we can cope with traditional way to get rid of it. For example, we can implement a backflush from our analyzer directly to clean the sampling, the sampling probe. And also, this is one of the feature of the low pressure sampling, that thanks to the small amount of gas we are collecting, this reduce also the pollution effect on
Okay, I see. So compared to the traditional system where you would have, let's estimate, a number of 3 liters per minute, which brings you to 180 liters an hour, 200 liters an hour to have a reasonable T90 time. Due to this higher flow, you have to suck more, so you would have more particles left on the filtration system, and due to the fact that you have a lower flow, also the number of particles which will stick to your filtration is lesser. Is that the okay?
Yeah.
Okay.
You understood perfectly.
Okay. Yeah. Okay. That's interesting. And regarding moisture, I think this is also the dew point question. I would say it's also interesting, right?
But but you're going way too fast.
Okay. Sorry.
I will show you with the other slides. We can go to the dew point just after that.
Yeah. Okay. Great. Sorry, Gary. Go on.
No problem.
No, keep it coming. Good question.
Yeah.
This is the gas path, but I think we got it now with the practical.
So as we said, the low pressure sampling is started at the sampling point, and we are adapting the pressure between 20 to 100 millibar absolute. So more than 10 times less than the atmospheric pressure. And that gives us, well, the pressure effect, first of all, on absorption, as the pressure, the low pressure is all the way in the sampling line, but also inside the cavity, the measuring cavity. You can see that there is clearly a great effect on the absorption peaks. In purple, the line in purple is the almost at atmospheric pressure, and the blue one is at 100 millibar absolute. And you can see that it allows us to differentiate and avoiding the cross interferences, or allowing us to measure different gases, as you just have seen in real, within one laser and one.
It draws a very clear picture, doesn't it? When you look at the 100 millibar compared to 800, you can really see a much clearer picture of what's going on in my sample.
Yeah, you can see on the right, particularly the right part is
wow. So is it? You can roughly say it's double the sensitivity, or not double, but it's quite an amount of,
It allows us to reach a very high resolution,
right?
And working with the OFCIAS technology, it allows us to get very, very precise results and very low limit of detection.
That's it.
Okay.
I mean, that's a whole new thing, Jörg. Maybe that's the next webinar. Is the measuring technique in the cell. But again, it's a big special part of AP2E. We could do a whole talk on it, but I think the next slide is quite interesting as well, because we really
You will see it in
This is
animated version. So
Jemson,
here we are.
Can you see the animation, Jemson? Yeah, right.
Yeah.
Yeah, the spectrum.
So you see, if we increase the pressure in the cavity, that the absorption peaks are vanishing, and you are not able to measure anything properly again.
Okay.
And here, back to low pressure sampling, you are able to distinguish different gases.
Yeah.
This is the absolute benefit of that low pressure system. Reduce the pressure, and you can see there a massive difference from atmospheric down to where we're looking at. And of course, you asked earlier about moisture as well.
Yeah.
Maybe Gary has.
I think that's the slide we were waiting for. So yeah, as you said, we also have benefits on the dew point, because basically we can say that at atmospheric pressure, everybody knows that the water is boiling, transforming from liquid to gas. And so if you are at 100 degrees Celsius, and if you go then below that temperature, you will condensate in the sampling line, in standard sampling lines. If we reduce the pressure, however, we reduce the same way the dew point. And that way it allows us to keep measuring into hot and wet gas without condensing, without conditioning the gas. And sometimes for STEM application, still we need to heat the lines because the amount of water is sometimes very important. But in most of the cases, we don't really need a heating line. So
which is bad news for us, but
not every time.
Still we need it,
and it could be that actually, I mean, a heated line may be 180. I don't know the most common sort of temperatures they run at, but it could be that we need something in the middle, maybe 80 degrees.
Yeah, no, that's a very, and maybe I can, because we have to keep an eye on the clock, and I can integrate also some of the questions, I think perfectly good to this. So what are the applications where heating lines are required at AP2E analyzer? That was one question which came from there.
A great question. Actually, we are saying basically that when you have more than 40% of water, 30% of water, we will start to need a heating line. So it's typically emission application when you have a lot of water in the stacks.
Sort of thing.
Yeah, exactly. When before the stack, you have some treatments, and then you have a lot of water. And otherwise it's in some very specific process application, I can say, when you have a lot of water.
And again, it might be that line doesn't need to be 180. But maybe 80.
Right. Yeah, exactly. If you compare to classical technology, maybe we would need only 80 degrees Celsius heated line or 45 degrees Celsius, depending on the amount of water. And that's one of the strengths, I think, of AP2E to being able to adapt.
If you're looking at your analyzer and your maintenance, your service, your cost of ownership, again, the temperature which you run your heated line, if you can drop that to 80 from a traditional method to an AP2E method, I'm sure there's cost savings to be had there over the lifetime of the analyzer.
It's not
only that, it's better to use less energy, right?
And I mean, I can just say from a technical side regarding the heated sample lines, if you only, let's say, have to keep up a temperature of, let's say, 80 or 100 degrees C, we can use self-regulating cables. It's a very easy technology, I would say. So you don't need to worry about the temperature controlling and positioning of the PT100 temperatures and all this stuff. So I think that principle has some advantages. And Jemison, I think it's quite interesting because we always discuss with our customers the positioning of the probe of the pump. If you place this in between the heat exchangers, for example, and this is that makes a very much difference regarding the outlet dew point and the pressure situation. And I think Jemison is quite interesting to see how you can make use of these differences here, right?
Yeah.
Okay. Yeah. Okay. But
time's running. I know you.
Yeah.
So I don't know if
that's
we can go through many slides. One point I wanted to make, though, if I can. Sorry, Gary.
Yeah.
Sure.
Just however you do it, we're talking about low pressure sampling today. However you do it, you shouldn't underestimate the significance of sample handling when measuring gases. It's absolutely critical that your sample handling system is up to scratch, suitable for the application. I mean, for us, we were talking yesterday about leakage because we have a low pressure. So leakage in your system can totally sway a result. It's just an important point to make there that we really take care in trying to find the right solution and the right sample handling system. Otherwise,
so a leakage test is something which is very crucial and very important to the accuracy of your system.
Within the production of our analyzer.
Yeah, I think Gary, because I think we have to shut this cord short a little bit. But I would be super interested to see what is the components you can measure. I mean, that's for sure one of the main questions now, as the people understood the sample handling and the principle.
Let's go more into the possibilities of the analyzer. Maybe just one small point to confirm what we exchanged together actually just before. As we are sucking much less gases than classical solutions, as you said, we have much less pollution in the filter. Still, we have a filter, of course, to protect our system, and it allows to make the life cycle of the analyzer much longer and to protect it. And still, with the low pressure sampling right at the beginning, you still expand the gas and create an acceleration of it proportionally to the low pressure. So it still allows us to have very fast response time thanks to this system. If we continue, here is the table of all the gases we are able to measure with our analyzer. So as you have seen, we can measure in ambient air some ammonia, or I think there were methane and N2O. This is one of the application. And here it's the comparison between what gas we can measure and the Fleury application we can answer. For example, we have natural gas. Natural gas monitoring is very important in terms of H2S or H2O. And thanks to the low pressure sampling, we are able to go down into sub ppb level, even in some applications. We have also, as we just see, actually the ambient air monitoring. And this is for example, greenhouse gases or ammonia. What can I say? I think we have also in pure gases and what we call for gas manufacturers. I think this is a good opportunity also to provide solution for gas monitoring in various different gases, depending on the impurity, on the process before it. And
it's a great matrix. And here you see the ppb a lot, but you even see a ppt.
Yeah,
This is why it's critical to have the right sample handling and our LPS, our solution.
Wow, I think that's quite impressive to see the resolution, how high you can measure down. Huh? Impressive.
It looks like we're running out of time, Jörg, but
yes, we do, guys. So but I think I really want to thank you. As I said before, it's probably hard to imagine that at the beginning 60 minutes will run out so fast. I think there is still some questions open, but I would like to please you, and I can ensure our audience that they will be answered from our dear colleagues after this webinar, because we have some questions here which I think everyone will be interested in. So I would like to thank you for your time. I would like to thank you for your great preparation. Jemson, what do you think? I think it's
I'm impressed. It's a new thing to me.
I think it's just a complete new concept, and I think very interesting to consider. I mean, obviously, in this short amount of time, it's not possible, to go through all of these detailed questions, which will be there. But I think everyone knows how to find you and where to find you online on LinkedIn. Again, thank you very much for your time. Thank you very much for your preparation and for your very professional presentation. And but I think, again, confirmed, sample handling, very important.
Extremely important. And we are, thank you for the opportunity to talk about it today. Thank you to everybody that's watched the video live, and to everyone that watches it later. And of course, we see each other at a HEMA, and we can talk more. That's us to you, Jörg, and of course to everybody.
Thank you. Take care. Bye-bye, guys. Bye.
Bye-bye.